Let's begin simply. A black hole is not an object in the way a planet or star is. It is a place where gravity has grown so strong that it traps everything, even light. You can think of it as a bottomless well in the fabric of space, a place where the rules of the universe start to bend. Black holes can be born when massive stars collapse under their own weight. The star's core shrinks into a single point, the singularity, and around it forms the event horizon, the invisible edge beyond which nothing can escape. And yet, as destructive as they seem, black holes are not just endings. Sometimes they are beginnings, too. If you were looking at one right now, what colors would you imagine swirling around it? Our story starts in a distant galaxy. Two massive stars are born close together. They live out their fiery lives and both collapse into black holes. Now they orbit each other, not in hours, not in days, but over millions of years, slowly spiraling inward. They tug at each other, pulling space itself into waves that travel across the universe. These waves are called gravitational waves, the universe's way of telling us that something powerful is happening. When LIGO detected such waves in 2015, it was like hearing the echo of two black holes colliding over 1 billion years ago. It was proof that this cosmic dance is not just theory, it's real. As the black holes draw closer, they orbit faster. In the last seconds, they're moving at nearly the speed of light. Space around them twists, time slows down, and then they merge. The two become one. The collision releases more energy in a fraction of a second than all the stars in the visible universe emit in that same instant, but it's all in the form of gravitational waves. No explosion, no light, just ripples in space-time spreading outward forever. Can you imagine standing somewhere in the galaxy and feeling the very fabric of reality shift beneath your feet?
The new black hole is heavier than either of the two before, but not as heavy as you'd expect. Some of their mass has been turned into pure energy, the waves we detected here on Earth. This black hole will now drift through the galaxy, perhaps to one day meet another and start the dance again. And in that thought, there is something quietly beautiful. Even in the darkest corners of the universe, there are meetings, unions, and new beginnings. You might be wondering, why should we care about two black holes colliding billions of light years away? Because it reminds us of how connected we are to the cosmos. The ripples from that event passed through your body the moment they reached Earth. They stretched and squeezed you, not enough to feel, but enough for our instruments to measure. It means the universe is not silent. It hums, it ripples, it remembers. And in a strange way, when two black holes became one, part of that story passed through you. So maybe we are not so small, after all. Maybe we are part of a much bigger dance, a dance as old as time itself.
Close your eyes for a moment and imagine the universe as a giant elastic ocean. When two black holes spiral together, they make waves on that ocean, gravitational waves. To our detectors on Earth, those waves arrive as a rising note, a brief chirp. At first, the pitch is low and faint. The black holes are far apart, moving slowly. As they draw closer, the pitch climbs and the loudness grows. The spiral tightens, the dance quickens. Right before the merge, the note rushes upward and then falls silent in an instant. That is the sound of space-time itself changing shape. Scientists turn those waves into audible sound by shifting them into a range our ears can hear.
When you listen, you're not hearing gas or thunder. You're hearing geometry, the shape of space, vibrating. It's like hearing a distant bell toll underwater, except the water is the fabric of reality. Here's a simple truth that still feels like magic. Mass can become energy. When the black holes merge, a small part of their combined mass doesn't remain in the new black hole. It becomes the energy of the outgoing waves, the music you just imagined. Even a tiny fraction of mass is enormous in power because of one short equation: E equals mc squared. Think of a single sun's worth of mass turned into pure wave energy. It would outshine the entire visible universe for a brief moment, if it were light. But these mergers shine in gravity, not light. The power leaves as ripples in space-time, not as a flash in the sky. This is why detectors need to be so sensitive. They are listening for a gigantic event that barely nudges us. Like feeling the faintest tremor from an earthquake on the other side of the Earth, we measure a stretch smaller than a proton's width. Small signal, colossal story. Isn't it wild that something so gentle on Earth can carry the power of several suns spent in a heartbeat?
When the two become one, the newborn black hole isn't perfectly calm. It's a little wrinkled, a little uneven, like a struck bell that still shivers with sound. This settling phase is called the ring down. During ring down, the black hole radiates a final pattern of gravitational waves with very specific tones. Those tones depend only on three things: mass, spin, and, if present, electric charge. Though astrophysical black holes are expected to have almost no charge. Measure the tones well enough, and you can read the black hole's identity, like scanning a cosmic barcode. This is a deep test of how gravity works. If the tones match what Einstein's theory predicts, space-time is behaving as expected. If they don't, something new and revolutionary may be waiting for us. If you could ring a black hole like a bowl, what note would you want the universe to sing? Not all black holes are tidy dancers. Some spin rapidly, some spins lean at odd angles to the orbit. When spins are tilted, the whole orbit can wobble. This is called precession. Precession changes the shape of the gravitational wave signal in time. To a scientist, that wobble is a gift. It carries clues about how the pair formed. Did they start life together as two massive stars, aligned like a well-practiced duet? Or did they meet later in a crowded star cluster, with random tilts and twists, a chaotic dance floor? Spin also matters for the final black hole. Spins that line up can make the final black hole spin faster. Spins that fight each other can sap rotational energy and even change the direction of the final kick. You'll meet the kick next. The way a black hole leans while it spins can write its origin story into the waves we hear. Mergers aren't always quiet good nights. If the two black holes have unequal masses or mismatched spins, the final waves go off slightly stronger in one direction. By conservation of momentum, the newborn black hole kicks the other way, like a rocket with no exhaust, only gravity waves as thrust. These recoil kicks can be gentle or wild. A small kick keeps the remnant near home. A big kick could fling it out of its star cluster, even in extreme cases, out of its galaxy. Imagine a lone black hole drifting between galaxies, carrying the memory of a violent union. Do we see the aftermath? Indirectly, yes. Unusual black holes, far from where we expect them, or galaxies whose centers may be missing their usual heavyweight. As our measurements improve, we'll learn how often the universe punts its newborns into the dark. Here's a simple truth that still feels like magic. Mass can become energy. When black holes merge, a small part of their combined mass doesn't remain in the new black hole. It becomes the energy of the outgoing waves, the music you just imagined. Even a tiny fraction of mass is enormous in power because of one short equation: E equals mc squared. A single sun's worth of mass turned into pure wave energy would outshine the visible universe if it were light. But these mergers shine in gravity, not light. The power leaves as ripples in space-time, not as a flash in the sky. That's why our detectors must be so sensitive. They are listening for a colossal event that barely nudges us. Like feeling the faintest tremor from an earthquake on the other side of the planet, we measure a stretch smaller than a proton's width. And yet, doesn't it feel almost unreal that something so gentle here carries the power of several suns spent in less than a second? When two become one, the newborn black hole isn't instantly calm. It's slightly misshapen, a little uneven, like a struck bell that still shivers with sound. This settling phase is called the ring down. During ringdown, the black hole radiates a final pattern of gravitational waves with very specific tones. Those tones depend only on three things: its mass, its spin, and, if present, its electric charge, though astrophysical black holes are expected to be almost neutral. By measuring the tones, we can read the black hole's identity, like scanning a cosmic barcode. This is a deep test of how gravity works. If the tones match Einstein's predictions, space-time is behaving as expected. If not, something new, and perhaps astonishing, could be hiding in the data. And if you could ring a black hole yourself, just once, what note would you want the universe to sing back to you? Not all black holes dance neatly. Some spin rapidly, and some spins tilt at odd angles to their orbit. When those spins lean, the whole orbit can wobble, a motion scientists call precession. Precession changes the shape of the gravitational wave signal. To an astrophysicist, that wobble is a gift, a clue about how the pair formed. Did they live and die together as twin stars, aligned like a perfect duet? Or did they meet later in the crowded chaos of a star cluster, their spins tilted at random like strangers suddenly caught in the same dance? Spin also affects the final black hole. Spins that align can make it rotate faster, while spins that oppose each other can drain rotational energy. Sometimes the result even changes the direction in which the final black hole moves. Imagine being able to tell, just by listening to space-time, whether two giant cosmic giants were lifelong partners or strangers crossing paths in the dark. Mergers aren't always quiet good nights. If the black holes have unequal masses or mismatched spins, the last gravitational waves shoot off slightly stronger in one direction. By conservation of momentum, the newborn black hole kicks the other way, like a rocket that burns fuel made of space-time ripples. These recoil kicks can be subtle or wild. A gentle one leaves the remnant near its birthplace. A fierce one can fling it from its star cluster, and in rare extreme cases, out of its galaxy altogether. Imagine a lone black hole drifting in the darkness between galaxies, carrying the silent memory of a violent union. Astronomers may have already seen traces of this in galaxies that seem oddly light in the middle, or in black holes wandering where no star should be. If you could follow one of these cosmic exiles, how far would you travel before you finally turned back toward home? One of the strangest parts of the black hole merger is that for all its power, there is nothing to see with our eyes. Black holes have no surfaces. They emit no light. The space around them may glow if there is gas nearby, but the merger itself happens in darkness.
Instead, the performance plays out on an invisible stage, the very fabric of space-time. Our telescopes, which rely on light, cannot watch the union directly. Only instruments tuned to the gentle stretching and squeezing of space can catch it. It's like hearing an orchestra playing in a sealed room and knowing the music is there only because the floor beneath you vibrates. You can't see the violins, but you know when the last note fades. If you were drifting in the dark near such a merger, would the absence of light feel eerie to you? Or strangely peaceful? To hear this cosmic music, we built instruments like LIGO, 2 long L-shaped detectors, each arm stretching 4 kilometers across. Inside them, laser beams bounce back and forth between mirrors, measuring distances to a precision so fine it can detect changes smaller than a proton's width. When a gravitational wave passes through Earth, it briefly stretches one arm of the detector while compressing the other. That tiny difference is the signal. Computers translate it into the chirps and sweeps scientists recognize. It's a feat of engineering so delicate that it must filter out earthquakes, traffic vibrations, even the wind rattling the walls. We've made the Earth itself into an ear pressed to the universe's skin. Wouldn't it be something if one day we could simply step outside and feel these ripples against our own bodies without machines in between? The collisions we detect today are not events happening now in the everyday sense. A black hole merger a billion light-years away happened a billion years ago. The waves have been traveling toward us ever since. By the time they arrive, civilizations may have risen and fallen near their source. The galaxy that hosted them may have changed entirely. So when we listen, we are hearing from the deep past, like catching an echo from a mountain we left long ago. Every merger we detect is both a message and a time capsule. It tells us not just about the event, but about the universe as it was when the first wave began its journey. If you could send your own ripple through space-time, knowing it might be heard a billion years from now, what would you want it to say? A merged black hole may seem like a void, but it carries an immense weight. The new singularity at its center is more massive than anything around it, yet it occupies no physical volume we can measure. All that mass compressed into a point so small it defies our understanding. The very idea challenges how we think about things. The event horizon marks the border, a sphere so perfectly dark that it is defined not by what it contains, but by what it will never let go. In the calm after a merger, this border is smooth, steady, and silent. There is a strange beauty in something so heavy that it reshapes the rules of the universe around it. Do you think of it as an ending, or as the start of a story we just can't read yet?
Black holes do not have to stop at one merger. In dense regions, globular clusters, galactic centers, a newly merged black hole might find another partner and collide again. Over cosmic time, this can create black holes of staggering size, the seeds of the supermassive giants we see in galaxy hearts today. Each collision sends out another set of waves, overlapping in time and space with countless others. Somewhere out there, multiple mergers could be sending ripples in our direction right now, their signals crossing and weaving like many voices in a single choir. If you could stand in a place where all these ripples pass through you at once, I wonder, would it feel like chaos or harmony? Far from our quiet blue planet, in the hidden reaches of the universe, black holes are not lonely creatures. They often drift within galaxies teeming with stars, gas, and invisible rivers of dark matter. In the cosmic dark, their gravity can pull them into a slow, spiraling dance with another black hole, sometimes taking millions or even billions of years before they finally meet. Imagine them like 2 phantom whirlpools in a vast ocean, circling ever closer, their orbits shrinking with each silent turn.
As they approach, the very fabric of space begins to ripple, not in light or sound, but in a deeper language, one the universe has spoken since its beginning: gravitational waves. Perhaps you can picture it now. Two invisible titans moving in perfect synchrony, their energy spilling into space like ripples across an endless pond. I wonder, if you could stand near the edge of such a pair, what would you feel? A tug? A hum in your bones? Or only the sheer quiet power of their presence? The moment of merging is not a collision in the human sense. There is no shattering, no sparks flying in a physical smash. Instead, the black holes slip into each other's embrace, their event horizons blending until there is only one, larger, heavier, and more powerful than either was alone. This is called a ringdown, a brief moment when the new black hole vibrates like a bell just struck, sending out one last cascade of gravitational waves before settling into stillness. Astronomers on Earth can detect this moment with delicate instruments, watching faint ripples in spacetime travel across billions of light years to reach us. And maybe, when you think about it, you realize this moment you are imagining right now is happening somewhere, in the darkness above your head, far beyond your sight. Does it give you a strange comfort to know that even the most massive things in existence are drawn together by an invisible pull, just as we are? After the merger, the new black hole is like a silent monarch ruling over its patch of the galaxy. It has swallowed not just its partner, but the entire story of their long dance. Every orbit, every gravitational tug now folded into its mass. Sometimes it spins with incredible speed, dragging the very fabric of space-time around with it, a phenomenon called frame dragging. If matter dares to fall toward it, the black hole can blaze with energy, forming glowing disks of gas and light so fierce they can be seen across the universe. Yet more often, it remains quiet, holding its secrets inside, letting only the invisible whisper of gravity mark its existence. And perhaps as you listen now, you might think of the strange symmetry between their story and ours, that endings in the universe are never truly endings, only transformations into something vast and new. If you could name this newborn black hole, what name would you choose? Imagine the merged black hole now, heavier than before, sitting in the quiet after the storm. Around it, the space seems calm, yet beneath that calm is a slow, steady humming, like a drumbeat deep within the cosmos. This rhythm is the new balance it has found, the way a river finds its path after a flood. We cannot hear it with our ears, but the universe feels it. Perhaps somewhere, another black hole senses the subtle shift in space, like two distant hearts somehow aware of each other's beat. And as you listen to this thought, maybe you can feel it too, a pull, a gentle sway, as if the universe itself is breathing beside you. Light still circles the new black hole in tight, dangerous loops. Photons dance at the edge, trapped in a cosmic waltz that will never end. Some escape, slipping into the open sea of space, carrying whispers of the great merger. If we could ride on one of those beams, we would travel across millions of years, crossing star fields and dark voids, until one day, perhaps, we reached an eye like yours, looking up at the sky and wondering what happened out there. This thought alone is strange, how the story of a black hole's embrace could reach us not through words, but through the very light that once skirted its jaws. Far from the black hole, new stars begin to stir. The merger has rippled through space, nudging clouds of gas, stirring ancient dust, and perhaps planting the seeds for new worlds. It's strange to think that destruction could lead to creation, but in the universe, endings are never just endings. They're openings. Somewhere, a small star is being born, its first flicker hidden in a cloud. One day, it might warm planets, oceans, forests, or maybe even eyes like yours. So as we sit here drifting in thought, can you imagine that in the shadow of two colliding giants, somewhere far away, a tiny sun is taking its very first breath?
If you could close your eyes right now and imagine the map of the cosmos, the galaxies like soft lanterns in a great ocean, could you find them? Could you feel where those invisible giants are pulling toward one another, their destinies written in curves of space-time? Perhaps, in some far-off age, beings not yet born will look back at this very moment and wonder what it was like to live in a universe where these dances still took place, where space itself could sing. And here we are, in our small corner of this vast and breathing cosmos, trying to listen, to understand, to remember that we are part of this great unfolding. Two black holes, born in fire, lived in darkness, and found each other across impossible gulfs, have shown us something profound, that even in the loneliest places in the universe, there is motion, connection, and the promise of union. And as the waves of their merger roll silently past our world, we stand in awe, not just of the science that reveals it, but of the mystery that remains. As we near the end of our journey, imagine those two merged black holes now as a single silent titan adrift in the ocean of space. Around it, the stars shine as if nothing has changed, yet in truth, space-time itself has been rewritten. The waves of gravity that once rippled outward have long passed, fading into the deep silence, like the last rings on a pond disappearing under the moonlight. You might wonder, out there, far beyond where our eyes can see, is another pair already dancing toward their inevitable embrace. The universe does not tell us directly, but its whispers are everywhere for those who listen. And so, the story of merging black holes is not just a tale of cosmic collision, it is a reminder that endings and beginnings are often the same thing. What seems like destruction is also creation, and what feels like loss is sometimes a doorway to something greater. In this way, the universe mirrors our own lives, folding moments together until the past, present, and future feel like one continuous thread. As you close your eyes tonight, let that thought drift with you. Somewhere, at this very moment, space is stretching, time is bending, and a new cosmic giant is being born in silence.